Okay, so let's just say this was the integral that we're given to compute. So if you think about what integration technique to use, you might eventually stumble upon something like trig sub, which is the right thing to do for this problem. If you want to sort of understand one way to think through which method to use, the first one should be like what you might call day one. In other words, do you just recognize this very clearly as a derivative of something that you can find the antiderivative of? That's for things like, polynomials, trig functions, exponential functions. I like sine or cosine functions. The next thing you might want to think about is, are there any like trig functions in this integral? In other words, do you see like a sine and a cosine, a sine squared times a cosine cubed, tangent, that sort of thing? And the answer is no. So you're not going to think about this as a trig integral. And then maybe if there's kind of stuff like this involving x squareds and something minus x squared, stuff like this, you might want to think in terms of trig substitution. And so that's how we're going to approach this problem. We're going to approach this problem using trig substitution. So I have a 9 minus x squared. So I'm going to tell you the way. You can memorize the formulas if you want. There's only 3 of them, so that's somewhat okay. But I'm going to tell you how I think through which trig sub to use here. I always start with the sort of most important thing we have, cosine squared theta plus sine squared theta is equal to 1. This should just be committed to memory. It should be, second nature by now. It's the Pythagorean theorem. And so if I rewrite this, I get cosine squared theta is equal to 1 minus sine squared theta. So whenever I have something like a constant minus a variable squared, or a constant minus something that involves a variable squared, I'm going to think about using this trig sub here. I'm going to sort of think about this as relating to the 9 and the sine squared as relating to the x squared. Okay, so what I need to happen, I need to make a trig sub. I have this 9 that I need to worry about. So if I look at this and I multiply this by 9, I get 9 cosine squared theta is equal to 9 minus 9 sine squared theta. And now I can basically match this up pretty exactly to what I have here. I can match this up pretty exactly to the 9 minus x squared. In other words, x squared needs to be equal to 9 minus sine squared, or I could say x is equal to 3 sine theta, because if x squared is equal to 9 sine theta, then x is going to be equal to 3 sine theta. And I need to take this and make all of my replacements over here. Replace the x, the dx, and the limits. Okay, so there's 3 things that I need to do. I need to, 1, replace the function. Replace the x's that are actually in the integrand. So I'll call replace the integrand. Two, replace dx. So in other words, figure out what dx is in terms of d theta. And 3, replace the limits, that is, the bounds on the integral. I'll call it the bounds on the integral. Okay, so that's what I'm going to do now. Of course, if you do this a lot, you don't have to write out all of these steps. But 1, replace the integrand. So let's just sort of work with what we've got here. So I'll just sort of make the changes step by step. Okay, so x is equal to 3 sine theta. So therefore, x squared is going to be 3 sine theta squared. And I'm going to do this in like a whole bunch of steps. I'm not going to skip anything. I'm going to do everything slowly and explicitly. I have 9 minus x squared. Okay, so x is 3 sine theta. So this is 9 minus 9. Sorry, I said I wasn't skipping steps. 3 sine theta squared. Okay, now dx, how do I figure out what dx is? Well, I come over here and I take the derivative of both sides with respect to theta. So I've got dx d theta is equal to 3 cosine theta. So therefore, dx is equal to 3 cosine theta d theta. Okay, so that's replacing the integrand, replacing the dx. Now I need to change the limits on the integral. So the limits on the integral, let me do a little bit of side work over here. So the lower limit, the lower given limit in terms of x is 0. So the lower limit is x is equal to 0. But notice x is equal to 3 sine theta. So now if x is equal to 0, but x is also equal to 3 sine theta, this tells me that 0 is equal to 3 sine theta. Okay, or this is equivalent to saying sine theta equals 0 if I think about dividing both sides by 3. Okay, so if sine theta is equal to 0, remember that our values for pi, when we do the sign substitution, our values from pi go from minus pi over 2 to pi over 2. And so the value of theta in this interval that satisfies this equation is going to be theta equals 0. So the solution here is theta is equal to 0. Again, there's infinitely many thetas, but only one in this interval. So now the lower limit is going to be theta equals 0. Okay, the upper limit, it looks kind of convoluted here, but we've got 3 to the power of 3/2 over 2. That's equal to x. But if x is equal to 3 sine theta, this is 3 sine theta. Again, if I try to solve this for theta, the first thing that I'm going to do is divide both sides by 3. And this gives me that. So when I do 3 to the 3/2 divided by 3, this is going to be the square root of 3 over 2 equals sine theta. And of course, there are infinitely many solutions to this equation, but the one that is in this interval here is going to be theta is equal to pi over 3, or 60 degrees. And so the upper limit here is pi over 3. Okay, so now I'm going to erase this scratch work and simplify this integral, because the whole point of doing trig substitution is to get to a simpler integral to compute. Right now it looks complicated. It looks more complicated, but I will simplify it. Simplify it using trig identities in particular. Okay, so let's see what's happening here with the constants first of all. I've got a 3 that's going to be squared. I've got a 3, so that's going to be 3 cubed. I'm going to have my integral 0 to pi over 3. Okay, so what's happening here? Well, I'll have my sine squared theta. In the square root, I'm going to have 9 minus, when I square the 3, that's going to be 9 sine squared theta cosine theta d theta. Now, there's a number of ways you can think through this. You can think about either factoring out the 9 and it'll come out of the square root as a 3, or just look at this identity that we have over here. 9 minus 9 squared theta is equal to 9 cosine squared theta. So this is equal, that's one way to do it. So I don't typically write things this way. And this is 3 cubed. I don't know where the 6 came from. So this is 3 cubed times the integral from 0 to pi over 3 sine squared theta. Okay, square root 9 times 1 minus sine squared theta cosine theta d theta. Now I can factor out the 9, but when it comes out of the square root, it comes out as a 3, and so I'll just pull it up over here. So we're going to have 3 to the power of 4. Okay, and so now finally what's going to happen, I don't have enough room to rewrite everything. 1 minus sine squared is cosine squared, and we're taking the square root. And again, so typically the square root of x squared is the absolute value of x, but for these values of pi, cosine is positive. For these values of theta, if theta goes from minus pi over 2 to pi over 2, cosine is positive. So then 1 minus sine squared, this is cosine squared. The square root of cosine squared is the absolute value of cosine. Since cosine is positive, that's just going to be cosine. So this is cosine theta. And then I have a cosine theta here, so I'm going to combine this together to be cosine squared, because I have cosine times cosine. And this is cosine squared theta d theta. Okay, and so this is this is how we would do trig sub to solve or to compute this integral. From this point, you would actually have to figure out how to deal with this integral here. You're going to have to use the half angle, double angle formulas to write sine squared and cosine squared in terms of cosine 2 theta, and then you can compute the integral from there. But this is the basic rundown on how to do this trig substitution when you're doing a sine substitution. I have a hard time remembering, which trig sub to do based on whether I've got 9 minus x squared or x squared minus 9 or 9 plus x squared. I always start by writing something like this and then rearranging it so I get something that looks like what I'm given. So over here I've got constant minus something squared. Here I've got constant minus variable squared. So it tells me that I need to be thinking about this substitution where I'm going to say x is equal to some multiple of sine theta.